Welcome to Math 7 Pre-Algebra. I am Mrs. Austin. This is our very first time going through with recording our lessons using this flipped classroom model. So be sure to give me some feedback on what you like, what you don't like, and we'll see if we can accommodate most of those requests. These videos will follow along exactly as they occur in your textbook. This lesson is on page 29 in your book. We are skipping the first section and moving on to lesson 2 of chapter 1, and you'll see the title up there, Variables, Expressions, and Properties. When you're going through these videos, be sure that you have your notables materials with you to take your notes and fill in your definitions and work your example problems as they occur here in the videos. The problems that I work in the videos are different than what are in your notes to give you some time to practice to make sure you're understanding the material that's being presented. So here we go, a variable. Okay, a variable is a symbol, and it's usually a letter that we use to represent a number. The branch of math that involves expressions and variables is called algebra. And when we have numbers and variables and mathematical operations together, we call those algebraic expressions. There's an example, 2 times n. That's an algebraic expression. 3x minus 5 would be an algebraic expression. As long as it doesn't have an equal sign in it, it's called an expression. If we want to evaluate something, that means to find the value of it. When we evaluate is to find the value. First of all, we have to replace the variable with the value that we know it's equal to. And that will give us a numerical expression. Okay, once we have that numerical expression that only has numbers and operations in it, then we can actually find what it's equal to. To find the value of the expression, we have to know our order of operations, and you should already know those, but we'll review those anyway. One of the mnemonic devices you probably learned to learn your order of operations is called PEMDAS. PEMDAS. Please excuse my dear Aunt Sally is what the letters stand for. The P stands for parentheses. The E stands for exponents. The M and the D stand for multiplication and division. Those have equal priority, and how you decide which is done first is whichever occurs on the leftmost side first. If it's a multiplication, then you do multiplication first. If division is to the left, then you do the division first. They have equal priority, but it's from left to right, whichever occurs on the left. Same with addition and subtraction. They have equal priority, but whichever is on the leftmost side comes first. Several ways of showing multiplication in algebra. We will often see the letter X like this. That means multiplication. A solid dot means multiplication. Parentheses imply multiplication. Or just a number and a letter next to each other also represents multiplication. Expressions that we have here in this example, 7 to the superscript 2 and x to the superscript 3, these are called powers. And they represent repeated multiplications. 7 to the second power is called 7 squared, and it means 7 times itself 2 times. So that factor occurs twice, or that number. X to the third power just means x times itself 3 times. The common mistake that students make is they think x to the third power means 3x. They are not the same thing. So make sure you don't make that same mistake. So those are powers. Okay, now we're going to get into actually evaluating some algebraic expressions. I have a couple of examples here for you. The first one says 6 times the quantity x minus y in parentheses squared. And we want to evaluate that when x is 7 and y is 4. So the first thing we're going to do is we're going to substitute those values for x and y into our expression and rewrite it. So instead of x we have a 7, instead of y we have a 4. Then we use our order of operations. Remember, the P parentheses get done first. We have a subtraction in there in our parentheses, so we have to evaluate that first. 7 minus 4 is 3. Then we said we have to do exponents. Well, we do have an exponent here. 6 times 3 squared. 3 squared means 3 times 3, which is 9. So we have 6 times 9, which is 54. All right, our next example says evaluate the expression g squared minus 2g minus 4 if we know that g is equal to 5. Well, again, we're going to start out by substituting. Instead of the letter g, we're going to put the number 5 everywhere that g occurs, and then we'll use our order of operations to evaluate that. So we have 5 squared minus 2 times 5 minus 4. Exponents get done next because there's nothing inside the parentheses to evaluate. So 5 squared gives us 25 minus 2 times 5 minus 4. Well, now we just have one multiplication that needs to get done before we do our subtractions. So we have 25 minus 10 minus 4, and now it's just straight subtraction, and we always work from left to right. So we have 25 minus 10, which is 15, and take that minus 4, which is 11. Okay, another grouping symbol that you're going to see very often is the fraction bar. This fraction bar right here tells us that the stuff in the numerator and the stuff in the denominator get evaluated separately. Before we do our division, we have to evaluate these multiplications and additions and subtractions first before we do that actual division. So let's move ahead with this example. This one tells us that m is equal to 9 and n is equal to 5. So we want to go ahead and evaluate this expression. So we're going to substitute in first. Instead of the letter m, we are going to put the number 9. And wherever you see the letter n, we are going to put the number 5. In the numerator, we have a multiplication that needs to get done first. 6 times 9 is 54. And then 54 plus 4 gives us 58. In the denominator, we have 2 times 5. And then we're going to subtract from that the number 8. Well, 2 times 5 is 10. 10 minus 8 is 2. So we have 58 divided by 2. Finally, that's our last thing to do, is that division bar right there. And that gives us a value of 29. Okay, properties. A property is an open sentence that's true for any number. These 4 properties you will be working with very extensively this year, so make sure that you understand what they mean and how to use them, how to identify them. The first one is the commutative property, and it has to do with what order you do things. Well, for addition and multiplication, it doesn't matter what order we add numbers. 6 plus 1 is still the same as 1 plus 6. 7 times 3 is the same answer as 3 times 7. When it deals with switching the order of the numbers, that's called the commutative property. The associative property deals with grouping of numbers. So when you have 3 numbers, such as is given in these examples, if we group the last 2 together, we'll get the same answer as if we group the first 2 together. If I add 3 and 8, I get 11. Add 2 to that, I get 13. That's the same thing as taking 2 plus 3, which is 5, plus 8, which is still 13. So the associative property tells us it doesn't matter what order we group them. The distributive property says that if we have a number outside of parentheses with some things inside the parentheses that are added or subtracted, it doesn't matter what order we do things. The distributive property just says that whatever number's outside of the parentheses is going to get multiplied by each term inside the parentheses. So in this example, a times the quantity b plus c, well, I multiply the first term together, a times b, and that gives me ab. And then I multiply the last term together, a times c, that's ac, and there was a plus sign between them. Likewise, in the example below that, it's just that they're subtracted. Here's some example with numbers. 4 times 6 plus 2. Well, that's 4 times 6, right there, plus 4 times 2. You distribute that 4 through the parentheses by multiplying it by each term, and then whatever is in between there, you keep that. So that's the distributive property. We'll see that a lot. We'll be using that quite a bit this year. The identity property is this. The identity property says whatever number you start with, if we start with a number or a variable that we're going to call a, the additive identity is 0. If we add 0 to a, we get a back. So whatever we start with, we end up with. So if we start with a and we multiply by 1, we still get a back. 1 is called the multiplicative identity. Okay, so any number you multiply by 1 gives you the number back. Any number you add 0 to also gives you that number back. So those are identity properties. So here's some properties that I want you to identify. Let's see if we can do this. What's happening in this example? We have 3 numbers multiplied together, and it looks like we grouped them differently. In the left-hand side, we grouped the last 2. and in the right-hand side we grouped the first two. So which property dealt with grouping? Well, that was the second one we talked about. That was the associative property. Okay, we didn't change the order. It was still the 2, the 5, the n, same order, but we just grouped them differently. You may wonder if any of the properties that we had shown you apply to subtraction or division. If you can find what's called a counterexample. A counterexample is an example that shows that something is false, like a property that it's false, then the property doesn't apply. So I know in your homework assignment there will be some problems where you have to find a counterexample to disprove something. So let's take a look. State whether the following conjecture is true or false. If it's false, find a counterexample. So how about this one? Division of whole numbers is commutative. What does commutative mean? Well, the commutative property said, here's a reminder, that the order doesn't matter. And you can switch the order and you'll get the same answer. Well, is that true or false for division? We know it's true for addition and multiplication, but let's take a look. Is 15 divided by 3 equal to 3 divided by 15? Well, on the left, 15 divided by 3 is 5. But 3 divided by 15 is 1 over 5. Those two things are not equal. So then that is a specific counterexample. So then this is false. Division of whole numbers is not commutative, and we have provided a counterexample. Your assignment for tomorrow, please fill in your notable section 1.2, and those will be pages 6, 7, and 8. There are some examples, there are some definitions. Feel free to go back and listen to this as many times as you need to get your definitions, or look in your book and come to class with any questions you have. See you tomorrow.